Hello student, today we are discussing constant coefficient differential equation. It can be written as f dy equal to r, where fd can be written for third order differential equation as a3d cube plus a square d square plus a1d plus a0 y equal to r, where d may be written as d by dx, where we can say x is a independent variable. The solutions of this can be written as complementary function plus particular integral. The complementary function part will be the solutions of f d y equal to 0. We will put d equal to m and we get nth degree equation fm equal to 0. The solutions of this will give the value of m. If we suppose that third order differential equations, then we can write three solutions as m1, m2, m3. We will find out the independent solutions for m1, m2, m3. If you want to write for independent solution m1, that is equal to e key power m1x, where x stands for independent variable. For m2 we can write e key power m2x, and for m3 we can write e key power m3x. We let us suppose that all m1, m2, m3 are real and distinct root. Then complementary function can be written as c1 e key power m1x plus c2 e key power of m2x plus c3 e key power of m3x. If let us suppose we say real and equal root, real and equal. Let us suppose we say m1 equal to m2 and third root are m3. For m1 we can write the independent solution e key power m1x. For this, because these are repeated two times, we can write this next solution is x e key power m1x. And for this, we can write e key power m3x. So complementary function can be written for this one as c1 e key power m1x plus c2 x e key power m1x plus c3 e key power of m3x. We can write like this. So the by one solution we can find out the different solution with the multiple as 1x x square like this. If t is a variable, then we can multiply 1t t square and so. Where the imaginary root, let us suppose we say complex root are there, then we can write m equal to alpha plus minus I beta. The solution can be written alpha will be go to e key power, so CF will be equal to e key power alpha x, real part is here, and imaginary part will be c1 cos of beta x plus c2 sine of beta x, like this. If there is a repetition, then we can just write this one. If let us suppose, now we take the example. Let us suppose where the differential equation is d square minus 4 whole square y equal to 0. Let us suppose this is the differential equation. The complementary for complementary function we put d equal to m. Auxiliary equation can be written as m square minus 4 whole square equal to 0. N can be written as this power will say that it is the repeated root. Factor power means repeated root. We can say for single this m equal to plus minus 2, and because this is the power 2, that means again we can write plus minus 2. The complementary function 4 minus 2 is c1 e key power minus 2x. Because it repeat two times, so we can write plus c2 multiply by x and same like this. Then plus c3, for 2 we can write e key power 2x and plus c4 x e key power of 2x. Like this we can write the complementary function. Similarly, if we have the imaginary root, let us suppose I say d square plus 4, this y equal to 0. From here you can say that m will be equal to plus minus 2i, right? So complementary function can be written as e की power 0x and this c1 cos 2x plus c2 sin of 2x. Now we come the particular integral, and this complementary function will come in particular integral also. For pi will be written as 1 upon f of d and this r. On the basis of r, there is a different method to find the particular integral. Case 1, let us suppose we will say r equal to e की power of ax. The same type question may be there like cos hyperbolic ax, which can be written as e की power of ax plus e की power of minus of ax upon 2. Similarly, we can solve by this method as sin hyperbolic ax. That can be written as e की power ax minus e की power minus of ax by 2. And also we can solve by this method as e की power x, which can be written as e की power logarithm of a की power x. So we can write this is equal to e की power of x log a. Here a can be written as log a. The method of this, we will put d equal to a. We can write the method is 1 upon f of d e की power of ax. We can say put d equal to a in denominator, provided denominator should not be equal to 0. That means solution will be equal to 1 upon f of a e की power of ax. If by putting any rule, the denominator is 0. For this case, let us suppose if I put t equal to 0, this denominator equal to 0. Then we will differentiate, multiply by independent variable 1 upon denominator का differentiation f dash d, and then we can write this e की power ax. We can write this as a suppose as a new question and solve by that rule. If again equal to 0, then we will apply the same rule into x and again differentiation like this. Take example. For example, if I say, let us suppose d plus 2 whole square y equal to e की power minus of 2x. So CF के लिए put m d equal to m. We will find out m plus 2 whole square equal to 0. So m is equal to minus 2 minus 2. Put the value here. This one. CF is equal to C1 e की power minus of 2x plus C2x e की power minus of 2x. Now we will find out this one pi. So for pi we can write 1 upon d plus 2 whole square e की power minus of 2x. If we put d equal to minus 2, because here a equal to minus 2, this denominator part will be equal to 0. So apply the failure rule, multiply by x 1 upon differentiation of denominator, that is 2 times of d plus 2, and this e की power minus of 2x, like this. Now you can see that again if we put d equal to minus 2, again we can see that this denominator will be equal to 0. So again differentiation, multiply by x into x, 1 upon 2 into 1, d plus 2 का differentiation हो गया 1, and this e की power minus of 2x. Final answer will be written as CF plus PI. So we can write y equal to c1 e की power minus of 2x plus c2 x e की power minus 2x plus x square upon 2 e की power minus of 2x. You can write like this. For this you can write the generalized formula as if there is anywhere this d minus a whole power r y equal to e की power ax. You can see denominator if we find out pi. What is pi? 1 upon d minus a की power r e की power ax. If this factor is linear factor, so directly we can write the answer is x की power r upon factorial r e की power ax. Because this factor, if we put d equal to a, r time it will be 0. So we will differentiate r time and we will get x की power r upon factorial r into e की power x. We can take other example. Now we can take the case 2. Case second, let us suppose I say r equal to sine of ax or cos ax. In this case, we will put d square equal to minus of a square. If I multiply by d both sides, I can write d cube equal to minus of a square d. Similarly, you can write d की power 4 equal to minus of a square d square, and that is equal to minus a square की power 2. So when we write all the value here, the pi 1 upon f of d, let us suppose cos ax, for both sin ax and cos ax, the rule will be same. If there is any power of this trigonometric function, for example, if I say sin square theta, to convert all these in linear term, so we can write 2 sin square theta, that is 1 by 2, and this is 1 minus cos 2 theta, like this. To convert all the function into linear term, similarly you can write cos square theta, that 2 cos square theta minus 1 equal to cos 2 theta. That means we can write 1 plus cos of 2 theta upon 2. Like this, after applying the formula, we can convert the trigonometric function into linear function, and then we can apply this formula. After putting the value of this, like d square equal to minus a square, this one minus a square d, and this one, the denominator will be converted into linear term. So we can write this is as 1 upon alpha d plus beta, and this cosine of ax. After that, we will rationalize the denominator and then solve. If we rationalize the denominator, we can write this alpha d minus beta upon alpha square d square minus beta square. A plus b, a minus b, that is a square minus b square, cos of ax. Put the value of this, again d square, as minus of a square, and this we can just operate here and then write the answer. We take the example. You can understand better by the example. Take the question. Let us suppose I say d square plus 4 y equal to, let us suppose I say cos 3x. First I write the CF. For CF we will write auxiliary equations, that is dm square plus 4 equal to 0. We can say m equal to plus minus 2y. What is the CF? CF is equal to real part is 0. So e की power 0x and then c1 cosine of 2x plus c2 sine of 2x. Then we come the pi part, 1 upon d square plus 4 and this cosine of 3x. You can see here a equal to 3. So replace d square equal to minus of a square, that means minus of 9. So directly we can get the answer here 1 upon minus 9 plus 4 cosine of 3x. We get from here 1 upon minus 5 cosine of 3x. And finally we will write y equal to CF plus PI. You can take other example. If I say d square plus, let us suppose I say 9, y equal to sine of 3x, then you can find out easily the CF part. For CF part, m will be equal to plus minus 3i. So CF can be written as C1 cos 3x plus C2 sine of 3x. What about PI? PI will be equal to d square plus 9 sine of 3x. So you can see when we put d square equal to minus of a square, if we put d square equal to minus of a square, that this will be equal to 0. Denominator will be equal to 0. D square equal to minus of a square, denominator will be equal to 0. Differentiate this x 1 upon multiply by x differentiation of denominator, that is 2d, and then sine of 3x, and 1 upon d stand for integration. So you can write x upon 2 integration of sine of 3x dx. So answer is equal to x by 2 integration of sine 3x, that is cosine of 3x upon 3. So pi will be equal to minus x upon 6 cos of 3x. So in any case, any rule in future, if there is a denominator is 0, so always we will differentiate denominator and multiply by x. The rule will be same as rule number 1. We can take other question. Let us suppose I say d square plus 3d plus 2. This y is equal to sine of 2x. Let us suppose I say like this. Put the value of this, like we can say this sine 3x. Let us I take sine 3x. What is the value of d square? Here d square equal to minus of a square. That means minus of 9. What is pi? In this case we can write d square की जगह रख देते हैं minus 9 plus 3d plus 2 and this sine of 3x. We get from here, like state in the method, that 3d minus 7. So rationalize this one. Rationalize करने के लिए कर देते हैं 3d plus 7 and here is again 3d plus 7. Right? You can find out this is equal to 3d plus 7 and this is 9, and put d square equal to minus 9 minus 49 and then sine of 3x. This is equal to 9 9 81 81 and this is 90 90 130 minus 1 upon 130, 3 times of differentiation of sine 3x, that is 3 cos of 3x plus 7 sine of 3x. We can find like this. Now we come to rule number 3. Rule number 3 is r equal to e की power ax into b. In this case, pi will be written as 1 upon f of d e की power of ax into b. So take e की power x outside and replace dh d plus a. We get this f of d plus a and b, where b may be any function. You can take b may be any function of this one. Take example. Let us suppose I say d square plus 1 y equal to e की power 2x. and into cos x. This thing. Here you can see that m equal to plus minus I, CF will be equal to C1 cos x plus C2 sin of x. And what about Pi? Write the Pi equal to 1 upon d square plus 1 and this e की power of 2x cos x. In this case, you can see that a equal to 2. So replace d by d plus 2. When you replace d by d plus 2, so we can say e की power 2x outside 1 upon d plus 2 whole square plus 1 and write here cos x. And solve this. This converting as e की power 2x 1 upon d plus 2 whole square में d square plus 4d plus 4 plus 1 क्या हो जाएगा हमारे पास, that is 5 cos x. Now we will apply the formula for cos x. You apply cos x, so you can see that here a equal to 1 and d square will be replaced by minus of a square. That means it will be replaced by minus 1. Replaced by minus 1, you can write this is equal to e की power of 2x 1 upon this minus 1 plus 4d plus 5 cos of x. By simplifying this, e की power 2x 1 upon this is 4d plus 4 cos x. Taking 4h common and then it's like the factor that is equal to e की power 2x upon 4. You can write this d plus 1, d minus 1. Again write here d minus 1 cos of x. What is equal to e की power 2x upon 4. डोमेटर में आ जाएगा डी स्क्वायर माइनस 1. तो डी स्क्वायर की वैल्यू रख देते हैं माइनस वन एंड वी अप्लाई डी ऑन कोस एक्स दैट इज minus of sin x minus cos x. By simplifying this, you can write this e की power 2x upon 2 into 4 8 minus sign को ले लेते हैं, will get sin x plus cos x. This one, right? Now let us suppose you say d square plus 2d plus 1 y equal to 8 x e की power of minus x and let us suppose sin of 2x. We want to find out this one. So you can see that this is the m की वैल्यू क्या आ जाएगी, m equal to that is basically m square plus 2m plus 1 equal to 0. This is m plus 1 का whole square that is equal to 0. We can say that value of m equal to minus 1 minus 1. CF is C1 e की power minus x plus C2 x e की power minus x. Now we come to the Pi. So I can write in denominator as d plus 1 whole square. This right hand side we can write as e की power minus x outside and this can be written as 8x sin of 2x. Now apply e की power x into b. In this case, what is the value of a? You can see the value of a is equal to minus 1. So d will be replaced by d minus 1. So you can write e की power minus x and take 8 as also common. 8 upon 1 upon d की जगह हमने रख दिया d minus 1 and this plus 1 and this whole square x sin of 2x. By solving this, you will get d square. This is get of d square, so we can write 8 e की power minus x 1 upon d square x sin 2x. So integrations of x sin 2x. Apply the rule for integration of u into v, that is u पहला फंक्शन सेम, दूसरे का इंटीग्रेशन v1 डिनोट फॉर इंटीग्रेशन माइनस u डैश v2 प्लस u डबल डैश v3 लाइक दिस, अल्टरनेट प्लस माइनस साइन. फर्स्ट फंक्शन सेम, सेकंड का इंटीग्रेशन, देन फर्स्ट का डिफरेंशिएशन, सेकंड इंटीग्रेशन, फर्स्ट डिफरेंशिएशन, सेकंड इंटीग्रेशन. तो अप्लाई दिस फॉर्मूला हियर, you can find out x sine of 2x. You can see first function is x, sin 2x का इंटीग्रेशन क्या होगा, that is equal to minus of cos 2x upon 2 minus x का डिफरेंशिएशन 1 and this is minus of sin 2x upon 2 square. We get this. And 1 upon d square means we will integrate 2 times. So integrate this again and then we can find the answer. So this can be written as 8 e की power minus x, again integration, that is minus 1 by 2x cos of 2x minus 1 is यहाँ पे हो जाएगा plus 1 upon 4 sin of 2x dx. Again integrate. If we again integrate, this is equal to 8 e की power minus x. फर्स्ट वाले का इंटीग्रेशन कर देते सेम फार्मूले से, तो माइनस 1 by 2 एंड दिस इज इक्वल टू x फर्स्ट फंक्शन, सेकंड का इंटीग्रेशन क्या हो जाएगा हमारे पास 7 sin of 2x upon 2 माइनस x का डिफरेंशिएशन 1 एंड इसका इंटीग्रेशन क्या हो जाएगा माइनस ऑफ cos 2x upon 2 स्क्वायर. नाउ कम दिस वन प्लस 1 upon 4 sin 2x का इंटीग्रेशन क्या होगा हमारे पास minus of cos 2x upon 2. Solve this, we can get the answer of this one. Now we will take rule number 4. Rule 4. Rule number 4. Rule number 4, you can take r equal to x into v. So we can say, this is a very important rule. The many time questions will come. F of d x into v, that is equal to x 1 upon f of d into v minus f dash d upon f of d का होल स्क्वायर v. For example, let us suppose I say d square plus 1 y equal to let us suppose I say x cosine of 2x. Apply this formula. In this case, the after putting the rule, denominator should not be equal to 0. Otherwise, this rule will fail. So we can write the condition as for any rule, denominator should not be equal to 0. In that case, this method fail. To apply other proof method, right? We can write this pi equal to 1 upon d square plus 1 and this x cosine of 2x. Apply this rule, x 1 upon d square plus 1 cosine of 2x minus d square plus 1 का डिफरेंशिएशन, that is equal to 2d upon डिनोमिनेटर का स्क्वायर d square plus 1 का होल स्क्वायर cosine of 2x. Now you can see that here a is equal to 2. So d square की वैल्यू क्या होगी माइनस ऑफ 4 हो जाएगी. पुट d square इक्वल टू माइनस 4. d square की क्या रख देते हैं माइनस 4 रख देते हैं. पुट माइनस 4 that is equal to x 1 upon minus 4 plus 1 1 by 3 cosine of 2x minus 2d. तो ये क्या हो जाएगा आपके पास 3 का स्क्वायर cosine of 2x. We get this one. Now d means differentiation. इसे क्या करें डिफरेंशिएशन कर देते हैं. We will get x upon 3 cosine of 2x minus 2/9 cos 2x का डिफरेंशियल क्या हो जाएगा -2 sin of 2x. And finally you can write CF plus PI. This is the rule number 4. Okay, rule number 5. In this rule number 5, if I say R is the polynomial of x, R is the polynomial of x, then you can apply this formula. In this case, we will write 1 upon f of d polynomial of x. We will demonstrate this with example. First, I take the example. Let us suppose I say d square plus 2d plus 3, and this y equal to, let us suppose I say x square plus 3x. We want to solve this one. Take this one, pi equal to 1 upon d square plus 2d plus 3, and this you can take x square plus 3x. Okay, we can write first step 1. Step 1, take least degree term common from denominator, 1 upon 3, and this can be written as 1 plus d square plus 2d upon 3, and this, and you can write this x square plus 2x. Step number 1, this one. Write this 1 upon 3, 1 plus d square plus 2d upon 3, and this whole power minus 1 x square plus 2x. Apply here binomial expansion. You know binomial expansion? 1 plus a. Let us suppose I say 1 plus a whole power minus 1. The expansion of this is 1 minus a plus a square minus a cube. If you want 1 minus a whole power minus 1, the expansion of this is whole plus 1 plus a square plus a cube. In above formula, alternative plus minus sign. Similarly, you can write 1 plus a minus 2. That is 1 minus 2a plus 3a square minus 4a cube. And similarly, 1 minus a whole power minus 2, that is equal to, you can take whole sign plus 1 plus 2a plus 3a square plus 4a cube. Apply here the binomial expansion of this one, and degree of up to which degree we will expand. We write expansion. You can write this expansion up to expand up to degree that is equal to degree of polynomial plus degree of d in denominator after convert in binomial expansion. Real expansion. Okay. Here you can see that degree of this is 2. You can expand this one as up to degree 2 or term 2. 1 by 3, 1 minus is 1 minus d square plus 2d upon 3. And now plus a square. You can write a square is d square plus 2d upon 3 whole square, and we don't require next term, that is x square plus 2x. Simplify this. We can write this one is 1 upon 3, and you can write this 1 minus d square plus 2d upon 3. Take only the second degree term from this third term, this one. This is 1 upon 9 and second degree term is only 4d square. Rest one will be 0 due to degree of polynomial. X square plus 2x. Apply 1 by 1. 1 by 1 आप इसको अप्लाई कर दीजिए यहाँ पे. सबसे पहले 1 को करें. 1 upon 3 क्या आ जाएगा, डायरेक्ट आ जाएगा एक्स स्क्वायर प्लस 2x. नाउ कम सेकंड टर्म. इन सेकंड टर्म राइट माइनस 1 by 3 डी स्क्वायर. डी स्क्वायर को इसके ऊपर ऑपरेट करेंगे, क्या आएगा, एक्स स्क्वायर का आ जाएगा हमारे पास 2, दूसरा हो जाएगा 0. ओके, प्लस 2d प्लस 2d 2 टाइम्स ऑफ डी. डी का मतलब एक बार डिफरेंशिएशन क्या होगा यहाँ से, इट हो जाएगा हमारे पास 2x प्लस 2. ये होगा हमारा सेकंड टर्म. प्लस 4 upon 9 and 4 upon 9 when you can write this d square of this one that is equal to 2 and this one. Simplify this, you can find the answer. Take one example, more example, that is, let us suppose I say d cube plus 2d square and this y equal to, let us suppose, 4x. So I take this pi equal to 1 upon d cube plus 4d square and this 4x. Take least degree term common from denominator. Denominator में देख लीजिए क्या है आपके पास, least degree term क्या है, 4d square. So take this 4d square as common. We will get this one as 4d square common ले लेते हैं यहाँ से. That is 1 upon 4d square and from this we get 1 plus d upon 4 whole power minus 1 4x. Now up to which degree we should solve? Degree, this is 1 plus degree of this, that is 2. That means up to third degree we will solve. थर्ड डिग्री तक सोल्व कर देते हैं. 1 upon 4d square 1 minus a, तो 1 minus d upon a plus d by 4 का स्क्वायर minus d upon 4 का cube and this 4x. First we will apply this 4d, that means d. इस d स्क्वायर को आपको पहले क्या करना है, इस ब्रैकेट में अप्लाई करना है. 1 upon 4 तो क्या हो जाएगा, देखिए 1 upon d square minus 1 upon 4d plus 1 upon 16, डी स्क्वायर यहाँ पे कैंसिल आउट हो जाएगा, माइनस 1 upon 4 पक की पावर 3 कितना हो जाएगा, 4 4 जा 16, 4 जा 64 एंड यहाँ पे रह जाएगा d एंड देन दिस इज 4x. 4 से कट जाएगा 4. नाउ we can just apply this one. 1 upon d square means 2 टाइम इंटीग्रेशन. 2 टाइम इंटीग्रेशन ऑफ x क्या हो जाएगा, 1 होगा x स्क्वायर बाई 2 देन x क्यूब बाई 3, x क्यूब बाई 2 into 3 माइनस 1 by 4 1 टाइम इंटीग्रेशन x स्क्वायर बाई 2 प्लस 1 upon 16 into x and this one is minus 1 upon 64. x का डिफरेंशिएशन 1 and simplify this we get the answer. Okay, this is all. Thank you very much. If you like my channel then kindly subscribe my channel and pass to your friends. Thank you very much.